Hello, Algebra 2 students. We are going to start section 7.6, day 1, solve exponential and logarithmic functions. If you haven't already downloaded the notes, they're on the Google Classroom. You can take notes along with me or just pay attention. Remember, you can always stop the video and copy down what you need to get. If you miss something that I've said, rewind and start over. That's one thing nice about doing it this way. So the property that we're looking at is if b is a positive number other than 1, b to the x equals b to the y, and what we're missing is an if and only if x equals y. So if you can get the same base, then you set the exponents equal to each other. So you can see my example here. If I have 3 to the x is equal to 3 to the 5, x has to be 5 in order for this to be true. In order to do this, we're going to try to get the same base, and then we're going to set the exponents equal to each other and solve. It's a lot easier once you start seeing some example problems. So when we get to the first one, 4 to the 3x and 8. So I'm thinking 2 would be the base we want to find. So 4 is 2 squared. I'm going to put that in parentheses because that's what 4 is, and raise it up to the 3x. This one, 8, is 2 cubed. I'll raise to the x plus 1. I'm going to put parentheses around that just to keep it honest. All right, now remember when you have a base and you have the exponents next to each other, you multiply them together. So this would be, I'm going to set my exponents equal to each other. So 2 times 3x is 6x, and I would have 3 times the quantity x plus 1. If you could distribute that in your head and already have it done, that's fine. So we have 6x is equal to 3x plus 3. Subtract 3x from both sides, 3x equals 3. So x is equal to 1. And if we were to check this, this would be 4 cubed is equal to 8 squared. And we know that's true. So I won't be checking all of them, but that is true, so it worked. Coming over here to number 2. We see a 10 and we see a 100. Probably the base will be 10. We're going to leave this one alone. This becomes 10 squared raised to the 4x minus 5. So it's taking the exponents and setting them equal to each other. I have x minus 3 is equal to. Now this is going to be 2 times this whole quantity. So this will be 8x minus 10. And if we solve that, we bring this x over, bring that over, we're going to have 7x is equal to 7. So x equals 1. And you can check that and see that that's true. Anytime you want to turn the video off and try these on your own and then come back to see if you got them right, that's perfectly fine. This one, we're going to use 3 as our base. We'll leave this one alone and change this up to 3 cubed raised to the 2x. So x minus 7 is equal to 6x. And then, I just want to make sure I copied it right. Yes. I am going to subtract an x from the side, and I get 5x equals 7, negative that is, and x equals negative 7/5. Now I want you to know that it's easy for me to make a mistake. I make little mistakes here and there, and you guys know that. Without you raising your hand and correcting me, every once in a while that'll happen. And if it does and you see that it's just a silly mistake, if you can just go on without worrying about it, that'd be fabulous. 2 cubed, because we're going to use 2's, raised to the 5x is going to be equal to 2 to the 4th power. That's what 16 is, raised to the 3x plus 4. Now, since we have the same base, we're going to set the exponents equal to each other. I'm going to have 15x is equal to, distribute the 4 12x plus 16. Subtract 12x from both sides. 3x is equal to 16, and x is equal to 16/3. All right, number 5. We'll use 2 for the base. I kind of almost made that so I can't see it. 3x equals 2 squared raised to the x minus 1. 3x is equal to, don't forget to distribute that, 2x minus 2. X equals minus 2 is our answer. All right, think about what you would use for the base for number 6. 3 would be right. 3 squared, then that gets raised to the 2x is equal to 3 to the x minus 6. We don't have to do anything with that one. That one works out nicely. So we're going to have 2 times 2x is 4x is equal to x minus 6. Subtract an x from both sides. 3x equals minus 6, so x equals negative 2. All right. Now we're going to do another type of problem where they don't have, it's not nice and easy to look at this. So when we're going to be taking a logarithm of each side to undo the base, we take the log of both sides using that base. We want to find out 2 raised to what power is 7. How do we undo 2 as a base? Well, we take log base 2 of 2 to the x equals log base 2 of 7. Now recall, these will undo each other, leaving us with just x is equal to log base 2 of 7. We can't do this in our head. Some of our fancy calculators will, but we'll use a change of base formula. So this will be log of 7 divided by log of 2. And that's approximately 2.807. Here comes Macy. You can hear her little clicks on the floor. Now, if you plug that into your calculator, take 2 and caret, raise it to the 2.807, you're going to get really close to 7. Not exactly, because we did round. That's not an exact value. We did round. It'll be very, very close. It'll be 6.99 something, but it will work. That's why we put the little squiggles, because we've made an approximation. It's not exactly equal. This one's almost identical to this one, except now instead we're saying 2 raised to what power is 15, but we'll use the same steps. Log base 2 of 2 to the x is equal to log base 2 of 15. These undo each other, leaving us with x is equal to, and let's use a change of base formula. Now remember, we could use natural log if we wanted to. And that is approximately equal to 3.907. 2 raised to the 3.907 is very, very, very close to 15. Okay, next, let me move this down so that we can see all of it. There's example number 9. Okay, some of these we can still use the same base if they work out, but otherwise we're going to take the log base of whatever it is to undo it. In this case, we add 5 to both sides and we get 4 to the x is equal to 8. That one we could do log base, this is what we could do. We could do log base 4 of 4 to the x is equal to log base 4 of 8. And then we use the change of base formula to find out what that is. Or we could see that this is 2 squared raised to the x, and this is 2 cubed. So 2x equals 3 in this case, and x is equal to 3/2 or 1.5. And that's an exact answer. We don't have to do a squiggle. That would actually be the exact answer. And if you did this, if you did log of 8 divided by log of 4, you will find that it is 1.5 on your calculator. Okay, this one, we are going to subtract 3 from both sides. Okay, now we have 10 as our base. How do you undo a 10 as the base? Well, you take the log, because remember the log's base is actually 10. So log of 10 to the 2x is equal to the log of 5. Take the log of both sides. These two undo each other, and 2x is equal to log of 5. Divides both sides by 2, x is equal to the log of 5 divided by 2. When you push this in your calculator, don't forget to end the parenthesis around the 5, because if you don't end it around the 5, you're getting the wrong answer. And that answer is approximately 0.349. A little bit of rounding happening. 0.349. So if you took 10 and raised it to the 2 times 0.349 and then added 3, you'd get extremely close to 8. Now, you're probably wondering, why are we doing these types of problems? And it's funny that in honors physics right now, we are working with sound levels, and sound levels are in base 10 in decibels. So sometimes we have to solve equations by taking the log of both sides in order to find out the intensity of sound. It does have its applications in the real world. We're going to subtract 4 from both sides. 10 to the 2x minus 3 is equal to 17. And then we're going to take the log of both sides. Undo the 10. These guys undo each other. Whoop. And we have 2x minus 3 is equal to 17. Add 3 to both sides. Oops, forgot. Yep. I knew there was something around here. Log of 17. Excuse me for that. So we're going to add 3 to both sides. And then divide both sides by 2. So x is equal to log of 17 plus 3. Don't forget to end those parentheses around the 17 and do this whole operation before you divide it by 2. And that will be approximately equal to 2.115. This one's, first of all, we're going to isolate this x thing, so let's get rid of the 1. So we have 1/4. Don't cancel these out, because this is not a plain 4. This is 4 to the 2x. It does not cancel out. If it was just that, we could cancel, but it's saying we're going to take that and we're going to raise it to the 2x. We cannot cancel that, but we're going to get 4 here. And then we multiply both sides by 4. So we get 4 to the 2x is equal to 16. Now this is another one like the beginning. This is 4 squared. We can use the fact that we can get the same base. 4 to the 2x is equal to 4. 16 is 4 squared. So that means that 2x has to be equal to 2. So x equals 1. You can check that and see that that's exactly what's going to happen, because if we raise this to the 2 times 1, that'd be 4 squared is 16, divided by 4. 16 divided by 4 is 4, plus 1 is 5. It does work. So that is our answer. And that's exact. We don't have to put squiggles. That is what it is. Next, we are going to subtract 6 from both sides, and we get 10 to the minus 12x is equal to 94. Now we can't get that to the same base. We could have if it weren't for that 6. That 6 messed things up. So we're going to take the log of both sides. Undo the 10 by taking the log of both sides. These undo each other and we get negative 12x is equal to the log of 94. Divide both sides by negative 12. X is equal to log of 94 divided by negative 12. And x is approximately equal to negative 0.164. One more. Add 4 to both sides. 3 to the 0.01x is equal to 9. Hey, we can use the same base. 3's would work. So this is 3 to the 0.01x is equal to 3 squared. 9 is 3 squared, which means now these two are equal to each other. 0.01x is equal to 2. Divide both sides by 0.01 and you get x is equal to 200. That's an exact value. We didn't do any approximating there. Okay, if you have any questions, please email me. We're going to be doing a Zoom. I'll have that on the announcement. I will be giving you a worksheet to work on and telling you which problems to do for this part of it. That will be coming. I hope everybody is doing well. I miss you guys. Hi. I miss you guys. I hope this ends soon. Please take care of yourselves and your families. Social distance. Wash your hands. Don't touch your face. And get outside and enjoy this beautiful day. Take care.